Hello everyone, welcome to this video. In this, we are going to continue understanding mole concept relationships. We discussed about the number of moles with respect to mass, with respect to number, and we did a couple of questions for these two relationships. And we even interlinked these two relationships with each other and try to find some numerical based questions, try to find the answer out of it. So in this video, we are going to continue doing the same questions and we are going to discuss about the third relationship of the mole concept, that is with respect to volume. So we did these relationship number of moles is equal to given mass divided by molar mass, that is equal to given number divided by Avogadro constant. So we did till here only. Let's do another question. Calculate the number of electrons in 11 grams of carbon dioxide molecule. So now in this question they are asking electrons in 11 grams. So we'll try to write this 1 mole of carbon dioxide. We did the gram molecular mass of carbon dioxide in the previous lectures. So carbon is 12, oxygen is 16 into 2. So when you sum it up, it will give you 44 grams. So this is 1 mole. So 11 grams will be equal to what? 1 divided by 44, this will come over here, into 11. So this will be 1 by 4. So I'm going to keep it in the fraction because we need this 1 by 4 mole again for calculating number of electrons. So moving ahead, calculate the number of electrons. So we know 1 mole of carbon dioxide is equal to how many electrons? So we know Avogadro constant 6.022 into 10 raised to the power 23. So we need to multiply the total number of electrons in carbon dioxide. So carbon dioxide total electrons will be how much? We can add the atomic number over here for electrons because in this nothing is getting lost out of this entire molecule. Total electrons are going to be constant in this, even they share or they definitely share in carbon dioxide. So carbon atomic number is 6 electrons. Oxygen is 8 into 2 if you do it. So this is going to be so this is going to be 22 electrons. So into 22 electrons, this is 1 mole. So if we take the same number of moles that we calculated for 11 grams, so 1 by 4 mole of carbon dioxide is equal to what? So 6.022 into 10 raised to the power 23 into 22 into 1 by 4. So this will be so this will be 333.121 into 10 raised to the power 23 electrons. So we can shift the decimal also over here. We can write it as 3.3121 into 10 raised to the power 22. So this is our answer. So you remember how to interrelate these two concepts. So we can calculate number over here. We just did. We knew the mass. We knew the molar mass of carbon dioxide, and we knew carbon dioxide, this Avogadro constant. But the only thing that we need to understand, if we don't multiply the total number of electrons for carbon dioxide which are present in one molecule of carbon dioxide, so our answer will be wrong. So, moving ahead to the next relationship, that is calculation of number of moles with respect to volume. So, when we say volume over here, we are talking about specifically gases. So, this relationship we have to remember, 1 mole of any gas at STP. STP is standard temperature and pressure. So the temperature that we can consider over here is 0 degrees Celsius, or it can be 273 Kelvin. Pressure we can take it as 1 atmosphere, 1 bar, any value, the standard value. So 1 mole of any gas at STP that occupies 22.4 liter. So we have to remember this value. So it's a constant. So we can write the formula as number of moles that is equal to given volume divided by 22.4. So the given volume we can write it as V. So N number of moles is equal to given volume divided by 22.4. So this is another relationship. So if we do a simple question, calculate the number of moles in 11.2 liters of carbon monoxide gas. So it's a very simple one. You can do in the unitary method or you can do in the form of formula. So 1 mole of carbon monoxide gas occupies how much volume? So this is 22.4 liter. So 11.2 liter will occupy will be equal to how many volumes, how many moles? So 1 divided by 22.4 into 11.2. So this is roughly equal 1, this is 2. So this is half, that is equal to 0.5 mole. Now in this is one unitary method. Formula also is very simple. Number of moles given volume divided by 22.4 liter. So given volume is 11.2 divided by 22.4. This will again give you the same answer, 0.5 mole. Now one thing we need to remember over here, this is in liters. We can either use it as 22400 ml, or we can use it, so this I'm writing it over here, 22.4 liter can be equal to 22400 ml, 1 liter is equal to 1000 ml, or it can be 22400 centimeter cube, because 1 ml is equal to 1 centimeter cube. Or we can even write 22.4 liters, that is equal to 22.4 decimeter cube, because 1 liter is equal to 1 decimeter cube. These are all units of volume. So just remember that. Because sometimes in the question they mention in ml, centimeter cube, decimeter cube, so we don't have to confuse about it. We need to understand the relationship. It's a very simple logic. If it's given in ml or centimeter cube, then take this value 22400. If it is given in liters or decimeter, then take 22.4. Now if we need to relate these three relationships, so number of moles that is equal to given mass divided by gram atomic mass or gram molecular mass, MW, that's a short form. that is equal to n by Na given number divided by Avogadro constant. This is equal to V by 22.4 liter. So all three are related to each other, and what's a connecting link? The connecting link is the number of moles. So we can relate with the volume given mass into 22.4 liter divided by mw will give you volume. Or we can do like this, given mass V into mw divided by 22.4 liter can be equal to mass. We can compare with the number also, number into 22.4 liter divided by Avogadro constant is equal to volume. Then number can be equal to volume into Avogadro constant divided by 22.4. So I'm not doing anything special over here with these formulas. I'm just making up these formulas from these relationships. So we can relate at a time two relationships, this one and this one, or maybe any two. So if it's required or if they have asked all three in one particular question, then why not? We can relate all of these. So if you see one pattern in these formulas, they are all divided by some constant value. Gram atomic mass is never going to change for any element, for a particular element. And gram molecular mass or formula mass is never going to change for any molecule or compound. Similarly, Avogadro constant is a constant value. 22.4 liter is also constant. So I'm not discussing how this 22.4 came over here. We can discuss in any other lectures, but not over here. So now we'll take up one more question. Calculate the volume of 23 grams of sulfur dioxide gas. So in this question, we need to understand they are asking volume and they have given weight. So if you, again, what's a connecting link? Connecting link is the number of moles. If it is weight given divided by the gram molecular mass of sulfur dioxide, you will get the number of moles. Put those same number of moles equal to the volume relationship, V by 22.4, and you will get V over here. So we'll do it. 1 mole of sulfur dioxide. So one more thing, in this question we should know the formula of sulfur dioxide. If that is incorrect, you will calculate the gram molecular mass wrong. So sulfur is 32 over here. Oxygen is 16 into the number of atoms, that is 2. So we'll get 64 grams. So 23 gram will be equal to how many moles? 1 divided by 64 into 23. So again, I'm going to keep it in the fraction for the time being so that we can put this relationship, put this value in the next relationship. So 1 mole of sulfur dioxide is equal to how much volume? It occupies how much volume? 22.4 liter. So we have the number of moles that we calculated. 23 divided by 64 mole will be equal to 22.4 into 23. See, you don't have, we are doing crisscross only. So this 1 will go in the denominator, 22.4 divided by 1. So I'll write it into 23 divided by 64. So this is not going to, we don't have to do it reciprocal over here. It's going to be directly multiplied. So we can calculate 22.4 into 23 divided by 64. That is 8.05 liters. So that's our answer. So I hope you have understood this question. Now I compared volume and weight, so we can compare the number and volume in the next question. Calculate the number of atoms in 40 liters of ozone gas. So in this question, if you can see, they are giving us ozone gas. So I hope you should know about ozone chemical formula. It's O3. Three oxygen atom covalently bonded with each other to form one molecule. Now they're asking number of atoms in specifically how much volume, and they're asking in 40 liters. So how we can proceed? Again, volume is given divided by 22.4 liter. Then put the same number of moles equal to the that relationship, the number capital N divided by Avogadro constant. But again, they are asking us the number of atoms. If we don't consider the actual number of atoms in ozone, our answer will be wrong. Moving ahead, 1 mole of ozone gas occupies 22.4 liter. 40 liter will be equal to how many moles? 1 divided by 22.4 into 40. So I'm going to keep it in the fraction only over here. Next step, 1 mole of ozone gas occupies how many atoms? 6.022 into 10 to the power 23 into 3 atoms. Again, if we don't do this step, if we don't multiply into 3, our answer will be wrong. 40 divided by 22.4 mole will be equal to how many atoms? 6.022 into 10 to the power 23 into 3 into 40 divided by 22.4. So we'll solve it. 6.022 into 3 into 40 will give us 722.64 divided by 22.4. This will be equal to 32.26 into 10 raised to the power 23. So over here also into 10 raised to the power 23, it will remain same. So you can shift the decimal. So these many atoms, so it can be 3.226 into 10 raised to the power 22 atoms. So I hope you have understood these concepts, how to put it in the question, so how to relate each other. So we can do one more question. Calculate the mass in grams of 60 liters of sulfur gas molecule. So they have given us the volume. So volume is 60 liter. And they're asking the mass in grams of sulfur gas. Sulfur gas is S8, which is octatomic, having 8 atoms covalently bonded with each other. So 1 mole of sulfur S8 gas will occupy 22.4 liter. 60 liter will be equal to how many moles? 1 divided by 22.4 into 60. So again, I'm going to keep it like that. Then 1 mole of S8 molecule is equal to how much weight? Grams. So that is going to be 32 into 8. I'm not keeping it as one number because we have to cancel most of the things or multiply again. 60 divided by 22.4 mole of sulfur molecule will be equal to 32 into 8 into 60 divided by 22.4, these many grams. So we can calculate 32 into 8 into 60. Divided by 22.4. This is coming to be quite a big number, 685.7 gram. So these questions which I'm discussing, like I'm making it right now just for practice. These are not discussed in any of the books. So 60 liter is quite a big volume. So based on that, the weight will also be higher. So 685.7 gram, that's your answer. So I hope you have understood these concepts. We'll meet again in the next video. Thank you for learning with me.